Good morning. Okay, today we're going to take a look at rational exponents, meaning fractional exponents, and nth roots. So to start, let's just review our basic exponent rules. If you haven't watched my video on mad spam, go click on this link, then come back and join us. But meanwhile, we're going to do just a quick review of it. So here's what the MA stands for. When your bases are the same, meaning you're raising the same thing, that's called a base, and you are multiplying, you add your exponents. M stands for multiply, A stands for add. So here we are. A to the M times A to the N. When you multiply, you add, that would be A to the M plus N. So for example, 2 to the 3 times 2 to the 5 would equal 2 to the 8. One thing I want you to notice, you do not change your base. That stays the same. And you're taking your exponents and you're not multiplying them, but rather when you multiply, you are adding your exponents. Okay, next problem. A to the M divided by A to the N. When you divide and your bases are the same, you subtract your exponents. So that looks like A to the M minus N. So for example, 2 to the 5 divided by 2 to the 3. Is our 2 going to change? No, it's not. But 5 minus 3 leaves us with 2 to the 2. That's right. Okay, right here. A to the M to the N. When you are raising to a power, you multiply your exponents. So that becomes A to the M times N. And for example, 2 to the 5th raised to the 3rd becomes 2 to the 15th. Okay, a couple of properties. When you have A times B to the M, you apply that exponent to each piece of your base. So that will become A to the M, B to the M, multiplication. This is when there's multiplication here. If there is addition here, that's different. That's a binomial. Then you're going to write them both out in FOIL. A great example here would be 2x to the 3rd. So we apply that to the 3rd to each piece, and then 2 to the 3rd is 8. So 2x to the 3rd becomes 8x to the 3rd. Okay, similarly, when we have A over B to the M, we apply that M to each piece. So that becomes A to the M over B to the M. So for example, x over 2 to the 3rd becomes x to the 3rd over 2 to the 3rd, and 2 to the 3rd is 8. Great. Okay, to remind you, A to the negative M. Negative exponents do not have anything to do with negative numbers. What they mean is 1 over the positive version of that exponent. So A to the negative M becomes 1 over A to the M. So for example, x to the negative 4 becomes 1 over x to the 4. And then our last basic is to remind you that anything raised to the 0 power is 1. I like to say a cow to the 0 is 1. Okay, take a moment if you'd like, take a screenshot here. This is the basis of our exponent work. Now we're going to go ahead and take a look at nth roots and rational exponents, which means fractional exponents. Okay, so here we go. A to the M over N, we have a fraction as an exponent. So here's the deal. The denominator of your fraction is the power of your root. The numerator of your fraction is the exponent. So A to the M over N would get rewritten as one of the following: the nth root of A to the M, or the nth root of A raised to the M. It does not matter whether you put your exponent on the outside of the root or on the inside of the root, you get the same answer. Let's take a look at an example of that. 4 raised to the 3 halves. Okay, the first thing I'm going to do is I'm going to rewrite this. So I'm going to rewrite that as the square root of 4 to the 3rd. Now, I put this 2 here so that you could see where it goes, but we all know that square roots are written without the little number there. So whenever you see just a plain root sign with no number, there's an implied 2 there. The same way when you see an x with no exponent, there's an implied 1 there, right? Okay, 4 to the 3rd, that's 64, and the square root of 64 is 8. We know it's positive 8 because we started with a positive number here. let's take a look at it the other way. If I had rewritten this to begin with in the following way, the square root of 4 to the third, okay, the square root of 4, that's 2, and then 2 to the third, that's 8. So you can see that whether we put the exponent inside the root or outside the root, we get the same answer. All right, let's take a look at our next guy here. Now, do you remember from our previous what a negative exponent means? Negative means 1 over the positive version. So this is a raised to the negative m over n. And it doesn't matter whether our negative is attached to the m or attached to the n or attached outside the whole thing, the result is the same. So we are going to say that a to the negative m over n is 1 over a to the m over n. And that would be right there. All right, now in another video, we'll discuss how you are not allowed to have roots on the bottom of a fraction and what you would need to do to rationalize that. Rationalize is the word for how to get a root out of the bottom of the fraction. Okay, the next trick I want to show you is that when you have the nth root of two things multiplied together, that is the same thing as the nth root of one of them times the nth root of the other one. And this goes in both directions. If you have the nth root of a times the nth root of b, as long as the power of the root is the same, you can put that multiplication all under the square root sign. The same thing is true for division. If you have the nth root of a divided by b, then that is the same as the nth root of a over the nth root of b. And again, that goes both ways. So depending on what you're given, you may find it easier to combine them or to separate them. For example, let's say you are given the following problem. The square root of 2 times the square root of 18. 2 does not have a perfect square root. 18 does not have a perfect square root. We could reduce it and combine like terms, but 2 times 18 is 36, and that does have a perfect square root. So if I rewrite this as square root of 2 times 18, then that's the square root of 36, which equals 6. Similarly, let's say I have the following problem. The square root of 31 over 9. 9 does not divide into 31 evenly, but 9 is a perfect square. So if I take this and I separate it instead, the square root of 31 divided by the square root of 9, and then the square root of 9 can simplify just to 3. And now I've made my life easier. All right, so that is your introduction and explanation of nth roots, rational exponents, and just a quick review of your basic exponent work. All right, check out these videos. Consider subscribing to my channel so that you know when a new video comes out. And as always, keep on mathing.